Hello? Oh, I'm not even on the note page. There you are. Okay. I know, second time in a row, second day in a row, no music. I'm slacking. This is Unit 5, Lesson 2. I told you that we'll be able to access and use our reference sheet, so I'll make copies of this for everyone. Okay, so you have it to use on every single test and quiz for the remainder of the year. Okay, you've seen it in Algebra 1 and Geometry, so we'll be able to use it in Algebra 2 and everything we do from here on out. We're still talking about sequences, arithmetic and geometric. So the formula that they use for the Regents exam, we might as well get going with that one. We'll just use that. So it's the arithmetic sequence where a sub 1 equals a sub n, equals a sub 1 plus n minus 1 d. Okay, so that's the formula that we will use for our recursive definition. It's called an arithmetic sequence. Okay, so generate the next three terms of the given arithmetic sequence. We saw previously how you just keep plugging in for the previous term. That's what f of n minus 1 is. It's the previous term. Okay, so hopefully, we can get a little quicker with this. F of 2, f of 3, f of 4, next three terms. So what this means is the previous term. So 2 plus 6, 8. 8 plus 6, 14. 14 plus 6, 20. Okay, so you should not have to keep plugging in every single time. And I know we had quite a bit of fluencies to do, but if you did them, you probably got better at them, and it's going to help you in the long run. Now, to apply the formula for an equals a1 plus n minus 1d. All right, what we keep doing, the difference is we're adding 6 every single time. So if I have a2, plugging right into the formula, a sub 1 is 2 plus n minus 1, so that's 2 minus 1, 1d, which is 6. 2 plus 6 is 8. I can go right to a4. Look, a4 has a1, which is 2 plus 4 minus 1 is 3 times 6. 6 times 3, 18 plus 2 gives you that 20 that we got. Okay? So you can use the rule or the definition for any value. And it works the same here in the next one for the next three terms. So a2 is going to be a1. I don't know if you can see it with me over there. Can I move? Okay. And a1 plus n minus 1 d. Okay, because the d is 1/2. It's going to keep going up by 1/2. So 3/2 plus 1/2, okay, gives you 4/2, which is 2. A3 is going to be the 3/2. I know it's tough to see here. I didn't do it on the board first. Plus 2 times 1/2. So that's 1. So you have 3/2 times 1, which is 5/2. Okay, now if you need to pause it and copy it, go ahead. I just don't have enough room. So then A3, come on, what the heck is going on here? A3 is A1 plus n minus 1. I just did that, didn't I? Yes, I did. I want A4, right? All right, sorry. Because I already did 2, 3, so I need A4. See what happens when you erase it? A4 is 3/2 plus, what do I have? 4 minus 1, 3 times 1/2. Okay, so that gives me 3/2 plus 3/2 equals 6/2, which equals 3. Okay, now, sum number t, the first three terms of the arithmetic sequence are 2t, 5t minus 1, and 6t plus 2. What is the numerical value of the fourth term? So we want to solve for t. So what should happen is the difference from the first to second should equal the difference from the second to the third. So I have 5t minus 1 minus 2t will equal 6t plus 2 minus 5t minus 1. You got to put it in parentheses because you have to distribute it through. So then on this side I have a 3t minus 1 equals 6t plus 2 minus 5t plus 1. Okay. We can bring all the t's to one side. So this is going to be these two together give me a 1t. So that means I have a 2t equals. This here, 2 plus 1 is 3. Add another 1 from this side, gives me a 4. So 2t equals 4, t equals 2. Okay, so that's the t value, okay? Not necessarily the difference. So if I plug it in, okay, for these values up here, so I plug in t is 2. That means I have 4 is the first term. 2 times 5 is 10 minus 1 is 9 is the second term. And then 12 plus 2 gives me 14. So my common difference is 5. I'm adding 5 to everything. So what is the numerical value of the fourth term? I have to add 5 to 14, and I get 19. Okay? A lot of different ways they're going to ask the question. We looked at a few of them the other day. Some of them are real tricky. All right, so it's important to determine a general term in arithmetic sequence. So yeah, that's what we're going up by. Okay, so in exercise 3, they give us an equals an minus 1 plus 3. So here's the previous term. Okay, here's your next term. The difference is 3. So determine the value. I think I might have to extend this page. Oh, there we go. Determine the value of 2, 3, and 4. So A2, A3, A4. If you're just doing this right in order, all right, you're just taking the previous term with A1 is 5. So A2 is 5 plus 3, which is 8. Okay, A3 is 8 plus 3, which is 11. A4 is 11 plus 3, which is 14. Okay, see how we're just taking the previous terms. That's it. How many times was 3 added to 5 in order to get A4? So 3 was added to 5 3 times, okay, to get to A4. Okay, 1, 2, 3. Oh, yeah, 1, 2, 3. And then use the result from part B to quickly find the value of A50. So A50 equals the formula. What's A1? Come on, get up there. A1 is 5. 5 plus n minus 1 d. The difference is 3. That should be a 50. 5 plus 49 times 3. Put in your calculator. 152. Okay? So that's how you get your, that's how you use your formula to arrive at any number at all. Okay? And then the formula, like I said, up above, it's the same one that we're going to use from the Regents exam. AN equals A1 plus N minus 1D. That's the formula we're going to use. Okay? Okay, I don't know if I'm missing this in my notes. If I am, I'll do it in class. I have an exercise 4, but I don't seem to have it on my sheet here, so or my computer. So if I am missing it, I'll do it in class with you tomorrow. The other one is the geometric recursive definition. So the geometric that we use from our reference sheet is going to be AN equals A1 RN minus 1. So the first one was a D, which meant difference. This one uses an R, which is a ratio. Okay. The previous one uses addition because it was arithmetic. This one uses multiplication. Okay, with the geometric. So generate the next 3 terms in the sequence. So if R is 2, so what do? We just have to have A2, A3, A4, and you're just multiplying. So 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Okay, that's it. That's all you're doing. Okay, now when they give you a formula, this right here is the R. That's the ratio. So you're taking the previous term, okay, and then multiplying it by 1/3. Okay, so they give you the F of 1, okay, which is the same as A of 1. All right, so what do we have here? We have the previous term. So F of 2 is going to be 9 times 1/3, which is 3. F of 3 is going to be 3 times 1/3, which is 1. F of 4 is going to be 1 times 1/3, which is 1/3. Essentially, we're dividing everything by 3. Okay, it keeps getting smaller and smaller and smaller. Again, you need to pause it, replay it, whatever you need to do. Okay, because I only got about 5 minutes left. The next one, the next 3 terms. So T2, T3, T4. So we take the previous term, 3 root 2 times root 2. So you'll always be able to use your calculator, luckily, because root 2 times root 2 is just 2 times 3, which gives you 6. Then I have 6 times root 2, which is just 6 root 2. And then I have 6 root 2 times root 2, which is 12. Okay? And again, put it all in your calculator. You're just using the previous term. And I know we took the time the last class to show every single step. I don't really need to see that anymore. Okay? We could just go right through it and use the previous term. Okay? So consider A1 is 2, AN equals AN minus 1 times 3. Generate the value of A4. Okay? So you're going through everything. All right, so what do we have? We have 2, 3, 4. These are A. Okay? So we have, you're timesing it by 3. So we have 2 times 3, which is 6. 6 times 3 is 18. 18 times 3, which is 54. Okay? Now, if you want to use this formula up here, A1 is 2 times 3, because that's what we keep multiplying it by, and then it's n minus 1. See that up there, n minus 1. So it's the fourth term, so it's 3 cubed. 3 cubed is 27 times 2, whoop, is 54. Okay, so that's what we're saying is how many times you need to multiply it by? 3 times. Determine the value of A10. Okay, so A10 is A sub 1 times R n minus 1. Okay, so it's 2 times 3 to the 9th power. Okay, put that all in your calculator, you get 39,366. So then, what is your formula? Like I said, it's the one that we're going to use from the regions packet. AN equals A sub 1 R n minus 1. Okay, so I finished with a couple minutes to spare, and we will see you in class.